Hi, everybody, and welcome to our next lecture. So in this one, we're going to look more about the shapes of graphs and then a little bit more with the frequency histogram and how to find the mean there, as that's a little bit more challenging than just finding the mean in a regular data set where we just add and divide. So let's start on the first page here. And I want to look at, so in your book, or this was the 7th edition from the year before, but questions 35 and 36 here. So it says in exercises 35 and 36, identify any clusters, gaps, or outliers. So if I look at the first one here, I don't see any gaps, right? Meaning the spaces between the data. And I also don't really see any outliers. Now, I do see this sort of tail right here, right? This does look like maybe it's a little bit skewed where we have a tail on the right, but there's no main outlier where there's one guy that seems to be a lot bigger than the others. There seem to be a few people, we'll say, or a few cars in this case, that are falling into the upper categories, but there's nothing, not one that stands out. So there are no gaps here. And there's really no outliers. I would say there's more of a tail or a skewness, but there's no outliers. We do have a cluster, so the biggest cluster is probably right in, here, like from here to here, as that biggest cluster. Or even closer to the center. Some of us may say from here to here is really where most of it is. So if we go from just the middlemost cluster, that would be from around 275 to 425 maybe. Or we could go 225 to 475. So if you notice here, your midpoints are all by 50s. So you kind of have to think about what's going on here. If this midpoint is 250 and this is 300, well, halfway in between that would be 275, right? So that's how we're getting that 275 estimate. We're sort of trying to guess where those boundary points are by looking at the graph. Now for the next one, there's definitely a big gap, right? We have a gap right here. And then I would also say that this is probably going to be an outlier. Because again, it sort of seems like it's one single point, right? Here's the one mark. It's one data point that's kind of hanging way to the right by itself. So that does appear to be an outlier. And again, as we go further into the class, we'll actually have formula that we can use to determine for sure if it's something is an outlier. But for now, we're just going to kind of guess a little bit at what it looks like. We also do have a tail here, right? So you do kind of still have this right-handed tail, much stronger than over here, but it's very heavy on that right side with that tail going down. Now for a cluster, the left side, I think definitely has a cluster going on here. Now maybe from here to here, if I do the whole thing. And again, a lot of this we're just eyeballing for now. So if you're thinking was maybe a little bit different than mine, I can understand that, right? But I see this kind of big group together on the left here. So it really starts around 450 and it goes up to around maybe, let's see. If I can read that. Looks like maybe 1950, somewhere in that range. Right? So I'm looking here at my midpoints. I have 600, 900, 1200, 1500, 1800. So we're going by 300s there. So if I go halfway between, 600 and 900, that's 750. So I'm just kind of trying to estimate here what I think these marks are on them. So this is all the data. Now, another person may say that, well, the biggest cluster, so kind of like over here, yes, this is one big group, but the biggest clusters in the middle would be these two, right? Most of the data is actually between those first two bars. So this is a stronger cluster here. And again, that goes from about 450 to maybe about 1050 on that graph. So you do have a big group here, like we did over here, but again, most of the data was within these 3 bars. Here, most of the data is within those 2 bars. That's sort of a stronger cluster that we see there. All right. In the next few exercises, again, just kind of looking at graphs and trying to understand some of the patterns that we see there. Without performing any calculations, determine which measure of central tendency best represents the graph data. Now, remember, central tendency refers to mean, median, or mode. So we're trying to decide, well, what could be the best center to use? Um, so in the first example, we're looking at how often do you change jobs? So we have things by categories, every 1 to 3 years, every 4 to 5 years, every 6 to 10 years, or stayed at one job more than 10 years. Now, if you look at those are categories, right? So this is actually qualitative data, right? It's not, we're not using an average there to say, oh, it's 2.5 years or a number, right? We're giving a range. So it's really is qualitative data. These are categories. So when we have categories, the most appropriate center that you should be using is mode. So the mode would be the largest one here. Whatever is the tallest would be your center or your mode. So if you have qualitative data, categories, mode is what you're going to use. Because it doesn't make sense to average these values or to find a median here, really. The mode is the most appropriate. Now, my other three data sets all are quantitative, right? Because I have height, heart rate, and BMI. Those are all numbers, so they are all quantitative. So we do have that. And then I'm going to kind of look at the shape of the graph. So for the first one, if I look at this graph, this one is pretty symmetric, right? It's, pretty evenly spaced along that center, right? It's kind of like a mirror image on both sides. So this is symmetric. When we have a nice symmetric graph or a bell-shaped graph like this, usually we choose the mean as our best option. We tend to really like the mean. That is your standard average there. If we have symmetric data, the mean is right in the middle. Now, the median is also a good option because it is also right in the middle, and so is the mode too here, right? The mode is also going to be in the center because it's the highest. But for symmetric data, really the mean is the one that we like the most. It takes into account every data point, and it's a good representative of it. This example here, it's a little bit not as perfect as this one, but it's still pretty symmetric, right? If I kind of look here, I get a pretty nice bell curve. I have the highest point in the center, and then I have pretty even bars on either side. I know maybe the right side is a little heavier, but it's still pretty symmetric. So for this one as well, if I have symmetric data, that bell-shaped data, then the mean is typically the best option there. Now, this last one here, you have a few things going on. It is quantitative, but you have a gap and you also have an outlier, or what appears to be an outlier. So this data is not quite symmetric. If I got rid of the outlier, this one looks pretty good, but I have that outlier there. So it's not symmetric. When you have data that is quantitative, that is not symmetric, it could be skewed. So it has like a very strong tail on one direction, or in this case, it could have an outlier. Then what happens in those cases is the median tends to be the more accurate choice. When we have an outlier, the mean gets pulled towards that outlier too far, or when we have a tail as well. So when we have a tail, an outlier, something that's not symmetric, and again, it doesn't have to be perfect, but this is pretty symmetric. This one clearly has an outlier going on here. Then the median is usually the more accurate center. And when I say more accurate, I mean it's the most in the middle, or it's one of the more common values as well. And again, you can still use the mode is still good, right? The mode is the highest, but we tend to not use the mode unless it's for qualitative data, if I'm being honest. Most often we're using the mean, and then again, sometimes the median if our data is pretty skewed or if we have an outlier. All right, just a couple more examples with graphs. And again, I like these because we do a little in class, but we really don't do as much. So this gives us just a little bit more here. Excuse me. So in exercises 59 and 60, the letters A, B, and C are marked on the horizontal axis, and you can see them in pink. Describe the shape of the data, and then determine which is the mean, the median, and which is the mode, and justify your answers. So first of all, if I look at this data, let's start with 59. I do see this really long tail here on the right. right? So I have this tail on the right. So the shape of this graph is skewed right or positively skewed because it's moving towards the positive direction there. Now some things I can point out. So when I have a skewed right graph, first of all, irrelevant of that, the mode is going to be the tallest one. So this is going to be your mode. And again, it's always going to be the highest, no matter which type of graph you have. If it's a bar graph, whether it's symmetric or skewed, the mode is always going to be the tallest bar that you have. So in this case, we're looking, and then that mode goes with A here. Right, so mode is right down here at A. Now, when you have a graph that is skewed right, what's going to happen is that mean is going to get pulled with that tail. So the mean gets pulled with the tail. So in that case, our mean is going to be C here. It's going to be the one that's furthest on the right. So the mean in this case, again, is going to be C because it's getting pulled with that tail. And then what happens for skewed, we said in our last example that when you have skewed pictures, the median is the best center, right? It's the most middle. So in this case, the median is the most, I'm going to call it the most middle of all of them. So it would be B, because B is right in the middle of A, B, and C on that graph. On our example over here, we basically have the opposite graph. So here you have a tail going to the left. So you have something called skewed left, or negatively skewed, because again, it's kind of leaning towards the negatives. Even though there's no negative numbers here, it's pointing in that direction. So we call it also skewed left or negatively skewed. Now, what happens here again, your mode is the highest. So the highest bar is this one right here. And if I go all the way down and match it up, I see that that matches up with C. So your mode is C. Again, it's always going to be the highest bar graph. Now, as I mentioned before, your mean gets pulled with the tail. So what's going to happen here is the mean is going towards the left. So that must mean that your mean here is going to be A. It's getting pulled on the left with that tail. And then your median is going to be B. Again, for anything skewed, that median is going to be your most in the middle and your center there. If it's symmetric, then what happens is the mean, median, and mode basically all match up in the center if it's perfectly symmetric. But if you have skewed, then that mean is getting pulled either too far left or basically too far right in this case. And the same thing happens with outliers as well. You would get pulled in that direction. All right, so that was a little bit more with graphs. And then the last piece I want to do in our video is I want to look at the mean of a frequency distribution. So we know how to do a regular mean or average, right? We add up all the data points and we divide by the number of data points we added, right? So if I added 7 things, I would divide by the number 7. And I think most students are pretty okay with that. The ones that get a little bit trickier are things like weighted means, or the example I'm going to do here are the mean of a frequency distribution, because they're not as straightforward. Now, when you find the mean using a frequency distribution, right, which is a table, they are approximations. So they're never going to be exact. I want you to kind of keep that in mind. When we use a table like this, again, a frequency distribution table, the ones that we've been making kind of all semester so far, the mean calculation is approximate. And the reason it's approximate is because we basically pretend that all the points are class midpoints. So for instance, here is a very simple frequency table. You have your classes on the left, and then so these are 2 different columns. And then you have your frequencies on the right. Now I know that there are 11 data points between 29 and 33, but I don't have the raw data here. It was not given to me. So I don't know what exactly they are. So what we do is we use the class midpoint as the estimate for them. So what I'm going to do is I'm going to find the class midpoints first, and I'm just going to kind of do some work here, and then I'll fix my table afterwards. And don't forget to find the class midpoint, you would take the lower and the upper values, so 29 and 33 here, we would add them first and divide by 2. And when you do that, sorry, this should say 33. I knew I had something written on there. That's a 33, not a 32. excuse me, and when you add them together and you divide by 2, you get 31. And then we do the same thing down the line, right? 34 plus 38, I add those together and divide by 2 and I get 36. For 39 plus 43, I add those together, divide by 2 and I get 41. And then finally, 44 plus 48 added and divided by 2 gives me 46. So what we're going to do, because I don't have the raw data, if I had the raw data, the best thing you can do is use your raw data. But I don't have that here. I have to use the table. So I'm basically going to pretend that all 11 data points are 31. And then I'm going to pretend that all the 12 data points from the next class are 36. And then I'll pretend that these two are both 41. And I'll pretend that these 5 are both 46. So we're using our class midpoints to estimate the raw data. So how you do the calculation is you're going to go ahead and take that midpoint and you're going to multiply it by your frequency as the start. So we're going to take 31 as our first midpoint and our frequency was 11 there. And when I do that, I get 341. And then I take my next midpoint and my frequency in the next row is 12. So when I multiply, I get 432. Next midpoint is 41. My next frequency is only 2, so I have 82. And then my last midpoint is 46, with the frequency being 5, so I get 230. And what you're going to do is you're going to add these up. And when you do that, you get 1,085. Now, why are we adding these up? Don't forget a mean or an average, the numerator is a sum, right? You're adding up all the data points. Well, what we're doing here by multiplying is we're actually still doing addition. Remember, multiplication is a shortcut for repeated addition. So instead of me writing out 31 plus 31 plus 31 plus 31 plus 31 and so on 11 times, I can just write as times 11. So you're still doing addition really, but we're just using a shorthand to make that a little bit faster. So your numerator here is going to be 1,085. Now, your denominator is still the number of data points. If you add these all up, you'll see that the sum of the frequencies is 30 here. So there are 30 data points. So what I'm going to do is my mean is going to be about that 1,085 divided by 30, which is about 36.16. Or about 36.2, and this was miles per gallon. That was what we're talking about here. So we use the same units. Like, don't forget, units are the same for the mean. And again, this is an approximation. If I had the raw data, I would go back to the raw data, absolutely, and I would do it the real way, right? Just add up those 30 data points, divide by 30, and get the actual mean. But if I don't have that, at least I can get an estimate from my table. Now, what I would encourage you to do is pause the video at this point and see if you can do the second one. So the second one is the same exact kind of problem. You're going to go ahead and find your class midpoints and then use those to help approximate the mean. So when you're ready, give it a try and then start the video up again. All right, so this time we're looking at 24 data points. So just a little side note here, our sum of the frequencies is going to be 24 instead. But again, I don't have the raw data, right? So I have to use my table to approximate this. So I'm going to start by finding my class midpoints. So again, the first row is going to be 22 plus 27. I'm going to add those together and divide by 2, and I get 24.5. And then I'm going to take it and multiply it by the frequency, which is 16. And I'll do the next row. So I would take 28 plus 33, add those up and divide by 2, and I get 30.5. So I would use 30.5 and multiply it by 2. And then do the same thing for the last 2 rows. So to save some writing here, I will tell you that your midpoint here is going to be 36.5, and my frequency is 2. And then my midpoint here is going to be 42.5, and again, my frequency is 4. So we find all of those midpoints, and now we're going to multiply by our frequencies. When I do that, I get 391 for the first row, 61 for the second row, 73 for the third row, and 170 for the fourth row. Then don't forget you're going to add these up, and what you should get is 696. Now we're almost done. To get the approximation, we're going to take that 696. This time we had 24 data points. And when we do that, we get 29 miles per gallon. Again, same kind of data here, looking at miles per gallon for our units. Now, I do also have an Excel video on how to do this in Excel. It still requires a lot of background work. You still have to find the class midpoints, or if you're pretty savvy in Excel and you know how to do that, you can do those on Excel. But it still requires a bit more work. So if you're interested, don't forget to check out the Excel videos in class. Again, this one's a little bit more advanced in Excel. It requires you to actually kind of make your own formulas. So it shows you how to do like multiplication in Excel, how to do addition in Excel, and then division. So if you're interested in something like that, check it out. I don't know if it's significantly faster, if I'm being honest, because it still requires a lot of work in the background, figuring out midpoints and all of that. But if you're interested and you like Excel and you want to learn more, then that's a great video for you to check out. Otherwise, there's not too many of these questions on the homework. There are a few here or there, but they're not too bad to do a few of these out by hand. If you have questions, please reach out to me. I'm always happy to answer them. And otherwise, I'll see you guys next time.